another very often asked question is determining the flame height or determining virtual origin of a fire, or perhaps determining a given temperature of a plume, the velocity of a plume. And so those do relate back to these configurations. So this in particular um, relates to flame height. So flame height is a function of the diameter of the pool fire along with the heat release rate given. So you look at this, you see the diameter is to a negative function, 1.02, so that's affecting the height related to, the size of the diameter is a direct correlation between the growth, the heat release rate of the fire is going to be limited, as that diameter grows in size. How high that flame is going to be is direct function of what's that diameter size. But with that, you can do some calculations now. Not all fuel packages are pool fires, so we could have, more of a, just a palette of material. That palette of materials on fire. So you could need to express that in non-circular fuel package, and so you can do an equivalent diameter by using this equation. So we'll also take a look at that in the workshop session, take a look at applying that for flame height. Now virtual origin is basically a made-up term, but the idea is the virtual origin of the fire is a direct relation to that heat release rate, again as a function of the diameter. And so just like with flame height, virtual origin, if we've got a non-circular package, then we need to convert that diameter to like a circular package. But the virtual origin is basically to determine a plume. We can do a lot of things with the plume related to temperature and velocity. The virtual origin is important for smoke control systems, as you guys probably saw in that session. So virtual origin has a lot of application for these in particular, temperature, velocity of the plume. But as we mentioned, the virtual origin is basically calculating, where we would say in terms of this base of the fire related to the mean flame height. The virtual origin can take a negative term, and that's again related to the negative here in the equation. So we'll look at an application of this in the workshop session.